Assalamu alaikum. This is Kamrul Hassan, lecturer, Department of Mathematics, Milestone College. My dear student, I hope you are fine and your study going on smoothly. Our today's topic, logarithmic differentiation, which is chapter number 9e. First of all, I want to discuss about some important formulas which is very helpful for logarithmic differentiation. If the exponent of any function is a different function or any function is formed by multiplication of some other functions, then firstly gives ln of the function can be determined. The derivative is so easily. Next step, have a look. If uv and w all are function of x, then determine the derivative of y equals to uv by w. Here y equals to uv by w. Now gives ln both sides. Ln y equals to ln uv w, and now ln y equals to, and now applying the formula of logarithm, so we can write here ln u plus ln v, and here minus ln w, and now differentiation with respect to x, we get here ddx of ln y equals to ddx of ln u plus ln v minus ln w, and now here ddx of ln y, it will be 1 by y, and here y ddx of y, here look at this ln u, we can write 1 by u into ddx of u plus 1 by v ddx of v minus here ln w, it will be 1 by w ddx of w. Now look at this, here 1 by y into ddx of y, so we can write here it will be therefore ddx of y equals to y into 1 by u ddx of u plus 1 by v ddx of v minus 1 by w into ddx of w, and here y equals to uv by w, so uv by w 1 by u ddx of u plus 1 by v ddx of v minus 1 by w into ddx of w. Look at this type of math, you can use this formula. Look at the board, here some formulas. Formula number 1, constant exponent of function f to the power c. F means function, c means constant. Here in this case you can apply this formula ddx of x to the power n, and formula number 2, exponent function of constant c to the power f. In this case you can apply this formula ddx of a to the power x, And formula number 3, constant exponent of constant, c to the power c. In this case, you can apply this formula ddx of c, c means constant. And formula number 4, exponent function of function f to the power f. Look at this. Firstly keeps ln at that function and eliminating the exponent, or you can apply this formula e to the power ln p equals to p. Now mathematical problem. Question number 1. ln x minus root over x square minus 1. Let y equals to ln x minus root over x square minus 1. Now differentiation with respect to x, we get ddx of y equals to ddx of ln x minus root over x square minus 1. Okay, for this part we know that the formula of ddx of ln x equals to 1 by x. For this reason we can write 1 by x minus root over x square minus 1 into for this part ddx of x minus root over x square minus 1. And we know that ddx of x equals to 1, and another formula is ddx of root over x equals to 1 by 2 root over x. For this reason we can write ddx of x, it will be 1, and this part here ddx of y equals to 1 by x minus root over x square minus 1 into ddx of x, it will be 1, and this part we can write root over x square minus 1, so it will be 1 by 2 root over x square minus 1 into, for this part x square minus 1, it will be ddx of x square minus 1. Okay, here 1 by x minus root over x square minus 1 into 1 minus 1 by 2 root over x square minus 1. And for this part all we know that the formula of ddx of x to the power n equals to n into x to the power n minus 1. For this reason ddx of x square, it will be twice x, and minus ddx of 1 means constant, so it will be 0. Okay, now 1 by x minus root over x square minus 1 into 1 minus twice x by 2 root over x square minus 1, and here 2 and 2 it will be cancelled, so 1 by x minus root over x square minus 1 into 1 minus x by root over x square minus 1. Now after this line we can write here ddx of y equals to 1 by x minus root over x square minus 1, and now we can apply LCM method on this part. Here our LCM will be root over x square minus 1, and here root over x square minus 1 minus x. Okay, for this part we can take common minus 1. So minus x minus root over x square minus 1, and here x minus root over x square minus 1 and into root over x square minus 1, and here look at this, x minus root over x square minus 1 and x minus root over x square minus 1, it will be cancelled. So our answer will be ddx of y equals to here minus 1 by root over x square minus 1, which is the required solution of question number 1. Now question number 17. Here let y equals to x to the power x. For this type of math, keeps ln both sides. Ln y equals to ln x to the power x. Here look at this, ln x to the power x for this x. Now for logarithm formula, this x come first. Okay, ln y equals to x ln x. Now differentiation with respect to x, we get ddx of ln y equals to ddx of x into ln x. And here we know that the formula of ddx of ln x equals to 1 by x. So we can write here for this formula, here 1 by y into, for this variable, ddx of y equals to, now here suppose x is u and ln x is v. Now we can apply the formula of ddx of uv, ddx of uv. So u into ddx of v plus v into ddx of u. So we can write x into ddx of ln x plus ln x into ddx of x. Now after this line, we can write here 1 by y into ddx of y equals to x into, here ddx of ln x, it will be 1 by x, and here plus ln x into ddx of x, it will be 1. Now after this line, ddx of y equals to, for this part it will be y into x and x, it will be cancelled, 1 plus ln x. Here look at this, y equals to x to the power x. So we can write ddx of y equals to x to the power x into 1 plus ln x, which is the required answer of question number 17. Now question number 24, x to the power x to the power x. Let y equals to x to the power x to the power x. Here keep ln both sides for this type of math. ln y equals to ln x to the power x. Now ln y equals to, for logarithm formula, we can write x to the power x into ln x. Now differentiation. With respect to x, we get ddx of ln y equals to ddx of x to the power x into ln x. Now for this part we can apply UV formula. So after this line here, ddx of ln y, it will be 1 by y ddx of y equals to, suppose x to the power x is u and ln x is v, so we can write x to the power x into ddx of ln x and plus ln x into ddx of x to the power x. Here 1 by y into ddx of y equals to, here x to the power x into, we know that the formula of ddx of ln x is 1 by x plus here ln x into, for this part we can write ddx of x to the power x, it will be x to the power x into 1 plus ln x. So we can write x to the power x into 1 plus ln x. Now for this two part, this part and this part, we can take common x to the power x. So we can write 1 by y ddx of y equals to x to the power x and 1 by x plus ln x into 1 plus ln x, and for this part 1 by y, so it will be ddx of y equals to y into x to the power x into 1 by x plus here 1 plus ln x into ln x, and here y equals to x to the power x to the power x. Therefore ddx of y equals to into x to the power x 1 by x plus 1 plus ln x into ln x. This is the required answer of question number 24. Now question number 27. X to the power cos inverse x. Let y equals to x to the power cos inverse x. Now give ln both sides, so it will be ln y equals to ln x to the power cos inverse x. For logarithm formula, we can write cos inverse x into ln x into ln x. Now differentiation with respect to differentiation with respect to x, we get d dx of ln y equals to d dx of cos inverse x into ln x. And here suppose cos inverse x is u and ln x is v, so we can apply the formula of d dx of uv. Now after this line, here d dx of ln y, it will be 1 by y into d dx of y equals to here cos inverse x into d dx of ln x plus ln x into d dx of cos inverse x. Here 1 by y into d dx of y equals to here d dx of ln x, we can write here into 1 by x plus here ln x into d dx of cos inverse x. The formula is d dx of cos inverse x is 1 by minus 1 by root over 1 minus x square. Now here d dx of y equals to y into cos inverse x into 1 by x, here plus and minus, it will be minus and ln x by root over 1 minus x square, and here y equals to x to the power cos inverse x, so we can write d dx of y equals to x to the power cos inverse x into cos inverse x by x minus ln x by root over 1 minus x square. This is the required answer of question number 27. Now question number 39. Let y equals to x to the power sin x plus sin x to the power x, or y equals to u plus v. Therefore d dx of y equals to d dx of u d dx of v, which is equation number 1, where u equals to x to the power sin x, which is equation number 2, and v equals to sin x to the power x, and which is equation number 3. Now from equation 2, we get u equals to x to the power sin x. Now keep ln on both sides. Ln u equals to ln x to the power sin x, and after this line ln u equals to sin x into d dx of sin x into ln x. Now differentiation with respect to x, we get here d dx of ln u equals to ddx of sin x into ln x. Now we can write ddx of ln u, it will be 1 by u into ddx of u equals to, here suppose sin x is u and ln x is v, so sin x into ddx of ln x plus ln x into ddx of sin x. Here 1 by u into ddx of u equals to, look at this, sin x into ddx of ln x is 1 by x plus ln x into ddx of sin x, it will be cos x. Okay, now after this line, here ddx of u equals to, for this part it will be u into sin x by x plus ln x into cos x, and u equals to, here u equals to x to the power sin x, therefore ddx of u equals to x to the power sin x, so we can write x to the power sin x into sin x by x plus ln x cos x. Here this is the result of ddx of u, and now again from equation 3, here v equals to sin x to the power x, and keeps ln on both sides. Now we can write ln v equals to x into ln sin x. Now differentiation, with respect to x, we get ddx of ln v equals to ddx of x into ln sin x. Now here x is u and ln sin x is v, so we can write here ddx of ln v, it will be 1 by v into ddx of v equals to, here x into ddx of ln sin x, so it will be 1 by sin x into ddx of sin, it will be cos x, plus ln sin x into ddx of x, it will be 1. So now we can write 1 by v equals to 1 by v into ddx of v equals to, here cos x by sin x, it will be cot x, plus ln sin x. And here look at this, after this line after this line, ddx of v equals to v into x cot x plus ln sin x, and here b is sin x to the power x, x cot x plus ln sin x, and here, okay, now we can write ddx of y equals to ddx of u plus ddx of v. So ddx of u equals to this one and ddx of v equals to this one. So we can write x to the power sin x into sin x by x plus ln x into cos x plus this one sin x to the power x into x cot x plus ln sin x. Here, this is the required answer of question number 39. My dear student, no more today. See you again in the next class.